Hello, my name is Tristan Shin, and today I'll be explaining 2014 number 5. So the problem is, let R be the shaded region bounded by the graph of y equals x e to the x squared, the line y equals negative 2x, and the vertical line x equals 1 as shown in the figure. So part A is find the area of R. So we're going to let the area be denoted by capital A. We know that the upper graph is y equals x e to the x squared as shown in the diagram, and the lower graph is y equals negative 2x. So in this area is just going to be the integral from 0 to our endpoint, which is 1, of the upper graph minus the lower graph, dx. So if we simplify this, we get that. So now we need to compute this integral. If you think about it, the antiderivative of x e to the x squared, well, why don't we just take e to the x squared first? If we take the derivative of this, then we get x 2x e to the x squared. So this is similar to this, except it's multiplied by 2, which means that our antiderivative of this will just be 1/2 of this. And the antiderivative of 2x is x squared. And we let this run from 1 to 0. So in plugging this in, we get 1/2 e plus 1 minus 1/2 minus 0, which is just e plus 1 over 2, which is our area. So part B is write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. So first, where is y equals negative 2? It's going to be somewhere down here. But if you notice, right here is actually the point 1, negative 2. So the line y equals negative 2 is just this line right here. And we want to rotate this region around y equals negative 2. So for each of these values of x, we're going to rotate from here and make a circle, but then we're also going to remove off this much and make that circle. So what are the radii of these circles? Well, for a point on this graph, the radius is going to be x e to the x squared plus 2, because we add this distance and we added 2 here. And what about for a point on this graph? We have negative 2x and again plus 2, because we lost this much, but then we still have this much radius. So these are our two radii, and the area of the circles formed are going to be pi r squared and pi r squared. So if we take the top one, the top circle, and subtract off the lower circle and find that area, it's just going to be this. So now that's for a particular x in this range. As x ranges from 0 to 1 though, we want to take this integral of the area. And it may be convenient just to pull out the pi out of the integrand. And since the problem just asks to write but do not evaluate an integral, we can leave our answer like this. So part C is write but do not evaluate. An expression involving one or more integrals that gives the perimeter of R. So to get the perimeter, we have three parts we need to get. The y equals x e to the x squared part, the x equals 1 part, and the y equals negative 2x part. So two of them, these two, are line segments, which means that if we know their start and end points, we can easily determine the length of those segments. So this point here is the origin, so it's 0, 0. And in part B, we already found this point is 1, negative 2. Up here, we know x is going to equal 1 from this line. So in plugging in x equals 1 to here, we get that y equals e. So the length of this segment is just going to be e plus 2. The length of this segment, we can use the distance formula, square root of 1 squared plus 2 squared. So this is square root of 5. And now we need to determine the length of this segment. To do that, we can use the arc length formula. So letting L be the length of that arc, we get that this is equal to the integral from 0 to 1, because those are the endpoints, of the square root of 1 plus dy over dx squared dx. So what is dy over dx though? We can use the product rule on y equals x e to the x squared to get that this is equal to e to the x squared plus 2x squared e to the x squared, which we can factor this as 2x squared plus 1 times e to the x squared. So now plugging that in here, we get that L is equal to integral from 0 to 1 square root of 1 plus 2x squared plus 1 e to the x squared squared dx. So now that we have the three lengths, we can just add them up to get the perimeter. So P, or the perimeter, is equal to e plus 2 plus square root of 5 plus integral from 0 to 1 of square root 1 plus 2x squared plus 1 e to the x squared squared dx. And since it just said write but do not evaluate, we can leave our answer like that. So if after watching this video you would still like some practice with these topics, there are some problems in our book which are similar to this that you can use. There's chapter 6.2, number 1 through 18, and chapter 8.1, number 3 through 18. I hope you enjoyed this presentation on 2014 number 5.